This is our video number 4, and what we're going to show here is how we have changed from onboard command using the potentiometers like we did yesterday. Now we're going to bring in external commands, voltage and current, via positions 11 and 12 with respect to board common. In order for us to do that, a few things have to happen. First of all, we need to remove JU3 from the board, from the regulator board, to bring in an external power supply that is connected to common. We have the board common, or we can just go to common here on the negative, and then we have the external voltage command coming in to TB1 position 11 and the current command to position 12. Now you can only do one or both, but if voltage command it's being applied externally, then JU3 must be removed, and you notice that we only have one terminal. The plug is only sitting on one terminal as opposed to shortening both. For current command, it is JU4, and all this is in the schematics. The other thing that we have to do is we have to verify that the voltage and current limit command are all the way to 100%, because if not, you won't be able to get the output. However, if you don't want to get the full output, you can always use this to trim what the maximum output is. Another part of the test that we're going to do is we're going to show the optional external enable status relay that it's connected to TB1 pin 7 and to the 30 volts on TB1 position 1, just the way it's shown here. And here we have our little relay. Alright, so let's go ahead. So now what we have, we're back again. We have our AC input. We don't have a DC output. We're looking at our feedback, and we've already enabled. The reason why we don't have any output is because although our voltage command it's at 10 maximum, our current command is not. So what we're going to do is we're going to be in current regulation, current control, and that's what our regulator shows. So now as Tony starts increasing that command, that's good, Tony. So right where we are approximately 3 volts. We have 77 volts DC, and here we have the corresponding output on the positive. Once again, we are on, by the way, we came back to the manual polarity command. We could have stayed. But now we can continue on until we get our full maximum of 305 volts. That's what we got yesterday. That's fine, because we just stayed at 6. There's our output. We get bring it down, Tony. More. It probably sad. Yeah. Sorry, give me more. And what about you? Okay.
The current.
And here we don't have output, so we're going to check why. We probably don't have a potentiometer all the way to 100%. It is. All right. And then check the other one to get 12. There you go. So the relay is still working. So there you are. You got 12 volts at 12 volts, and you got 305. Okay. Now let's go ahead and now keep the command at 12, Tony, and start bringing it down. The command will stay at 12. The current command. Okay. Now let's keep it at 12. Let's bring in the voltage command now. So again, we can calm down. We can stop there now. So we have 8.3 volts, that's fine, 7.5, we have 260, and we have the corresponding output, and now we are again in voltage regulation. We're in voltage regulation because the voltage command is less than the current command. And again, so we needed to have the potentiometers at 100%, we need to remove the corresponding jumper, and then bring in the corresponding input. And then we basically get again now. We can do transition polarity, and there it is again. This again in manual. the last thing that we want to do is we want to show or really, I'm going to just go ahead and bring this a little down so that when we do the test, we're not consuming too much power. Okay, and we're going to see if we can go across the relay. Again, once again, that it's a 24 volt DC relay that is picking up the 30 volts that it's attenuated here. Well, it's actually the 30 volts on TV1, the dealer position 1, and the enable status, which it is position 7. So here is position 7 and position 1, and that goes across the coil. And right now on this we have a common and the normally closed, but because the unit is enabled, it's open. So let's go ahead and inhibit, and we can hear that now the relay has changed. So this is an optional way for you to monitor. Go ahead, Tony, enable of that. Now, the last thing that we want to show here is something that unfortunately, you want to inhibit there, Tony? Something we're, in order for us to do that, we will have to disconnect this. But on TV4, we have, on position 12, we have our instant enable signal that in order, when the unit is up, it's 12 volts. And on position 1, we have 12 volts. So right here. So if we were to have a light, if we wanted to show how the light turns on when the unit is inhibited, the problem here that we have is that in order for us to show it here, we have to open this. We will have to open up the switch, because even if we were to disconnect this, this is a permanent connection between 12 volts and this I1 NOT, which is required for the board to enable. The only way that the unit will inhibit is if this switch that is normally open will close. Will normally close will open, and it opens only when the heatsink temperature gets to 93.3 C. And that's where this signal, it's not longer pulled up to 12 volts. This will come down to ground, and now we have ground and 12 volts, and that will turn this LED on. That's something that, unless we go into our terminal switch and get it out, the problem is that you don't want to get in there and remove it and then try it out again. So this is the end of this video.